Yeah, good evening everyone. Good evening. Check now, audio video okay or not? Verify audio video okay or not? Please verify audio video okay or not, so that we can start. Can we start? Yeah, so I'm starting now. I think everything all right. I think everything is all right. We can go ahead. Right? I'm starting. I'm starting now. Right? Let's start. I'm starting. So let's go to today's class. So this is the place where we stopped yesterday. Right? In the given simple graph, every vertex contain degree k. Right? In the given simple graph, every vertex contain degree k. Then it is called as k regular graph. In n vertex k regular graph, total edges are n into k by 2. Right? This is what we discussed yesterday. Right? This is what we discussed yesterday. Right? Fine. Now afterwards I said right, 80% discount. Right? Let me reiterate one time before going to start the class. Let me reiterate one time here, everyone. So 80% discount is going on for 2020, right? 2026 people. Crash course you can take, or RIC course you can take, or test series you can take. And one more thing I want to say to you, 15 full length tests are already free. 15 full length tests are already free. They are there, right? AIMTs, 15 AIMTs are already free. You can utilize all of them. Right? 2027, 2026, this is 2027 people, they can go for regular batch. RIC course for practice, test series also for practice purpose you can take. 2028 people can go to the foundation course. Right? RIC course for practice, test series also. If you have any doubt, you can contact me. That is perfect. Now let's start the today's class. Let's start the today's class. I think I am giving the date today. I think today's date maybe, I think 18. Yeah, 18, 12, 25. Today's date is 18, 12, 25. Right? I'm starting now. I'm starting. So in the yesterday's one, if you observe, we covered regular graph also. Right? We covered the complete graph also. We covered the, I think one more thing is null graph also. Now try to understand. Everyone try to understand now. Everything is ready. Everything is ready. Today's class, in my opinion, just started now. Today's class, in my opinion, just started now. Please make sure everyone will listen what I'm saying now. Right? Listen this. Listen carefully. Yeah, I'm starting. A here. It's a one more graph. Please careful. B here, C here, and D here. A, B, C, D. A, B, C, D. This is one more type of graph. So I completed the regular graph. I completed the null graph. I completed the complete graph. Now one more graph is coming. Please listen. In this graph, if you observe, 4 vertices are there. And there is a cycle also. So this is called C4. That means cycle graph with 4 vertices. Cycle graph with 4 vertices. Cycle graph with 4 vertices. Right? Try to understand. This is a cycle graph with 4 vertices. And one more thing, cycle graph with 4 vertices, of course 4 edges it contains. Then vertices are, number of vertices are 4. Number of vertices are 4. Number of edges also 4. Number of edges also 4. Vertices 4 and edges also 4. It is a cycle graph with 4 vertices, which is called C4. In the similar way, you can see this also: A, B, and C. A, B, C. So this is cycle graph with 3 vertices, C3. 3 vertex cycle graph. Cycle graph with 3 vertices. Cycle graph with 3 vertices. Right? And one more thing is number of vertices. If you observe clearly, number of vertices also 3, number of edges also 3. So be careful. Number of vertices 3, number of edges also 3. I am thinking that everyone is comfortable, right? And one more thing, try to remember. Cn. Cn means cycle graph n vertices. N vertex cycle graph. N vertices cycle graph. It contain n edges. Right? So I think no one having any doubt. Let me know any objection. So I started with the name cycle graph, right? So I will underline also those. Please be careful. Cycle graph. Cycle graph. Right? So, and one more thing is 4 vertex cycle graph. Right? And which contain 4 vertices and 4 edges. Similar way, 3 vertex cycle graph. Right? So 3 edges are there. N vertex cycle graph. N edges are there. That's it. So name maybe look like a confusion. Name is look like a very danger and all, but basically there is nothing. So let me know any objection. If anyone says, sir, I have this issue, let me know. We'll work accordingly. Check everyone. Ready, sir? I have this doubt. You ask me, I will help. Everyone. Try one time. Everyone try. Any doubt? Cycle graph also I done. I done the regular graph. Right? I done the null graph. I done the complete graph. Now cycle graph also done. If you okay, I can move to the next story. Can I move next? Do you have any doubt? Check one time. You don't have any doubt? Let's move to the next. Right? I think cycle graph is over. Now let's concentrate. Cycle graph is over. Now let's concentrate. Let me write here. One more model is coming. See, make sure everyone listen. So A here, B here. Everyone observe. A here, B here, C here, and D here. Careful. Everyone observe. It is C4. Everyone know. It is C4. Then what you do is for C4, observe here. C4, you have to do some small change. A, B, C, D. A, B, C, D. Okay. Whatever C4 is there, write as it is. In between, add one more edge, one more vertex, A, B, C, D, E. Just add the few more edges like this. Keep in the center. So if you observe clearly here, totally, the number of vertices became 5. This is called wheel graph. Something like wheel shape came. Check. So wheel graph 5 is, right? Wheel graph 5 is derived from cycle graph C4. The only thing what you have to do is add one more vertex in the center. And the center to all the people, right? Keep the edges. So this is called wheel graph 5. Some people are asking, wheel graph 5 contain how many vertices? Let me write wheel graph. Name is called wheel graph. W5 means wheel graph. Wheel graph with 5 vertices. Okay, that is okay. Wheel graph with 5 vertices. I understood. Wheel graph with 5 vertices, it's okay. Contain how many edges? Right? How many edges? If you observe clearly, it is came from C4. Na? It is came from C4. So 4 edges. It came from C4. 4 edges are there. And one more thing is from the center, for all the 4 people, I think 4 more edges. Plus from the center, 4 more edges. total it became, if you observe, 8 edges total 8 edges, which is nothing but, that 8 is nothing but something like that, 2 into 5 minus 1, 2 times of 4, which is nothing but 8. Why 2 times of 4? Because of it is C4, 4 edges. From the middle, for the 4 people, you have to write 4 more edges. Totally 4 plus 4, totally 8. I think to get the clarity, take one more example. Everyone observe, right? So one more thing I am trying. See this one. A, B, C. So this is, everyone knows C3. From C3, right? Let me draw once. A, B, and C, A, B, C, and D. So like this. So if you observe clearly, this is called as wheel graph with 4 vertices. Wheel graph with 4 vertices contain, it came from C3, na? Because of C3, 3 edges already. From the center, one more 3 edges. So 2 times of 3 edges, which became 2 times of 3, which became 2 into, because of C3, na? Right? That is totally same. 2 into 3, which is 6. Fine. So remember, right? W4, wheel graph with 4 vertices. W4 came from C3. Understand this. W4 came from C3. W4 came from C3. So we are deriving, right, from C3 only. Now I think to get the more clarity, I will write this note also. Can you see the note? Note. See this one. Wn contain n vertices. Okay. Wn contain n vertices. And how many, right? It came from the Cn minus 1. Na? It came from Cn minus 1. Means n minus 1 edges as usual, plus n minus 1 edges from the middle. Totally 2 times of n minus 1. These many edges. I feel everyone is okay. Ready, sir? I have some problem. Please write more. This is going to be n vertex wheel graph. N vertex or n vertices wheel graph. It is a n vertex wheel graph. Understand? N vertex wheel graph. Fine, perfect then. So let's go to this. Same thing here. Right, from here it is started. Actual game is started here. See this one. I think a 5 vertex wheel graph with 5 vertices. Main points I'm underlining, which contain 2 into 4 edges. Similar way. W4 came from C3. Okay. And right, W4 contain how many edges? It came from C3, na? 3 edges for cyclic graph, 3 edges from middle. Total is 2 into 3, which is nothing but 2 into 4 minus 1. Same thing I done for this also. Right? Note I written. I feel people got it. Maybe some doubts you can ask me. Ready, sir? I have this doubt. You ask me, I will help you. Check. Everyone try. Am I right or not? Am I okay or not? Everyone say, so that we will go to the next graph. One more graph is there, next graph. We will go to that graph. I'm expecting answer. Right? I think, can I go? Wheel graph also over, cycle graph also over. Wheel graph also over, cycle graph also over. Right? Now I am thinking, now I have to move to, right? One more major one. So bipartite graph. So what I can do is, let's give 1 minute. Let's give 1 minute. Let's give 1 minute. I'm sharing the screen. I'm sharing the screen. Give 1 minute. Yeah, this is. Now understand. It's a very, very important one. This is going to be very useful also. This is going to be very useful also. Please listen. Everyone listen. This is going to be very useful also. See this. Very useful. This is going to be very useful. Just wait. Yeah, I think everything ready. So this is going to be very useful. Everyone listen. In my opinion, the graph theory, this is the major part. In the graph theory, it is a major part. I'm writing here. See this one. Graph theory, it is a major part. See this. A. This is a very interesting one. This is a very interesting one. Everyone should listen. A, B. From now onwards, actual graph theory will start. D, C, and D. Okay. Right? And understand. This is the one graph. What kind of graph? It doesn't matter. Some graph. If really required, we'll think about. This is one graph. Right? Understand. This is one graph. Understand what I'm doing. There is a one graph, name is called G. What kind of graph it is? It's okay. Just take some graph. I took some graph. Name is G, which contain 4 vertices and 4 edges also. Everything perfect. Now what you have to do is, and in this graph, V vertices are there, assume. E edges also there, that also assume. Otherwise, I will remove this line. There is a graph which contain V vertices and E edges. Name is called G. Everything perfect. Now what you have to do is, understand. Divide is a very, very important one. Divide V into two parts. M and N. Or two sets. M and N. If you want, I will write. Divide M into two sets. Two non-empty sets. Divide V into two non-empty sets M and N, such that, careful, such that M union N is equal to V. Next one, M intersection N is equal to pi. Means nothing is common. Right? From the given graph, which contain V vertices, E edges, you have to divide the V into two non-empty sets M and N, such that M union N is equal to V. Means if I combine M and N, all vertices should come. If I do intersection of M and N, right, it should be pi. In my opinion, everyone is okay. Divide V into two non-empty sets M and N, such that M union N is V, M intersection N is pi. That is okay. And one more thing, remember, such that this is the one condition. It is the 2, that is okay. So can you see the 3? One more 3. See this one. All edges are from M to N only. But not from M to M, N to N. Please careful. That is the third point. Fourth one. Every edge of G should be covered. Every edge of G should be covered. What it means, you will get to know, right? If you can do this kind of thing, if you can do this kind of story, then I can say, right, these all conditions are satisfied. Then I can say, these all, whatever I written here, if it is satisfied, then G said to be, then G said to be bipartite graph. Graph G V comma E, right, where V is the number of vertices divided into two parts M and N, such that M union N is V, M intersection N is pi. That is our first two conditions. Next one, all edges are from M to N only, but not from M to M, N to N. Fourth one, fourth condition, every edge of G should be covered. Every edge of G should be covered. Then G said to be bipartite graph. I am sure you may not get it. I'm sure you are not getting. Yeah, with the help of example, you will get. Let's take one example. I'm sure many people not getting. You will get with the help of example. Let's see. So I'm starting now. See, check following graph. Bipartite or not? Check following graph. Bipartite graph or not? See the graph. A. This is the first example. Everyone should get it. It is the first example. A, B, C, D. You have to verify it is a bipartite graph or not. You have to verify it is a bipartite graph or not. See how I am doing. Is it bipartite graph or not? I have to verify. I am verifying. I am verifying. Is it bipartite graph or not? I am verifying. First thing, divide vertices into two parts, M and N. Okay, this is M. This is N. Okay, I divided M and N. That is perfect. And remember, divide V into two non-empty sets. Remember, M should be non-empty. N should also be non-empty. Both are non-empty. As of now, empty, but at the end, it should be non-empty. Right? Now see this one. Graph contain four vertices. Graph contain four vertices. Should be divided into two parts, M and N. M should be non-empty. N should be non-empty. See how I am doing. Let us assume A I written here. Assume. If A I written here, A to B edge there, na? A to B edge there. Remember, if two people are adjacent, definitely one point should be in the M, another point should be in the N. So, A to B edge covered. Two vertices are covered and one edge also covered. Let's see the one more edge. I think B to D there, B to D, B there here, B to D. So, D will be here. So this also covered. Now next one, this also covered. C to D, C to D. Let me check C to D. I think D here, C should be here. This also covered, C to D also covered. Next one, A to C. Remember A to C, A to C also, A to C. So if you observe clearly, all edges are covered. See the definition also. Graph contain how many edges? Every edge should be covered. Okay. Every vertex should also be covered. It's okay. M to always edge from M to N. Within the M, no edge. Check. Within the N also no edge. And one more. M union N is going to be all vertices. M intersection N is going to be pi. So every condition satisfied. Right? I drawn the same graph in another way. Right? It is looking like a two partitions are happened. It looked like a partition happened. So I am able to draw the same graph in the form of A, right? Dividing into two parts, M and N, edge always from M to N. Within the M, no edge. Within the N, no edge. Always edge from M to N. So this is going to be, if you observe clearly, this is going to be, then I can say that given a graph G. So this is the G assume. This graph name is assume G, which contain V vertices, E edges. Remember? So then I can say, then G, V, comma, E. is a bipartite graph. I think you got. Previously you didn't get, now you got. In my opinion, most probably everyone, okay, it's one of the very, very important topic. Total graph theory is running on this only. Total graph theory is running on this. Let me know anyone having any objection. Reddy sir, I have this objection. Hi. So crick. I don't know, someone crick saying hi. Hi. Hi crick. Thank you. Now let's move to next. I think one example I done. Let me do one more example. You will get more clarity. Let me do one more example. You will get the more clarity. See this one. One more example. Right? So let's use one more example. Careful. A. You have to verify given a graph is a bipartite graph or not. A, B, C, D. Right? Let's check. I am writing like this. This graph name is G. Assume V comma E. So is it bipartite graph or not? I have to verify. Means I have to divide into M and N, where M is here, where N is here. Edge always from M to N. Let us assume that M is A is here. A to B edge there. This is completed. Right? Next one. A to C edge also there. This also completed. A to B done. A to C also done. Next one. What about B to D? B to D. D here. This also completed. Next one. What about C to D? C to D. This also completed. But do you identify or not? This edge still left out. Let me cover that also. C to B. C to B. See. Edge going within this. Edge going within this. Edge going within this. So because of this reason, it is not bipartite graph. It is not bipartite graph. It is not bipartite graph. Careful. So this is the one more example. Check the given graph is a bipartite graph or not. No. Right? Simple. Are you able to divide the given graph into two parts or not? Right? Where two parts are M and N. Within M and N, no common vertex. And one more thing, no vertex should miss also. In the original graph, 4 vertices. Right? After doing union of M and N, all vertices should come. And after dividing into two parts, if I see the number of edges, previously how many, now also should be there all. One edge also cannot miss. Suppose you are able to cover every edge. Somewhere within the N edge came. Then it is not bipartite. Within M also edge came. It is not bipartite. Always edge from M to N. I hope you got. Right? So two examples I given for bipartite. Check the given graph is a bipartite or not. We have to verify is it bipartite or not. I verified. It is not bipartite. Right? Next one. One more example. See above one. Check the given graph is a bipartite graph or not. Right? So I verified. So it is a bipartite. Because everything perfect. Right? What is the definition for bipartite? See. Right? So given graph is said to be bipartite if you can divide the vertices into two non-empty sets M and N, where M intersection N is pi, M union N is V. So that those are the two steps. Third one, all edges are from M to N only, but not from M to M, but not from N to N. Fourth one, every edge of G should be covered. Every vertex should be covered. Every edge should be covered. If we can do this, means it is ready to divide. It is ready to bipartites. Means these conditions all satisfied. Means right means partition is possible. Name itself saying bipartite means bipartition. partitioning is possible. Means given a graph saying that I am allowed to bipartite. So given a graph is a bipartite graph. So given a graph is a bipartite graph, I feel everyone comfortable. Check the following graph, bipartite graph or not. So two examples we done. Now let's move to right. Two examples over. Now let's move to right one by one. Careful everyone, let's move to one by one, right? So I'm trying one small line. So please listen careful. Bipartite graph. Just give once 1 minute. Just 1 minute. Just wait. One small. Just one more minute. Yeah, fine. Now so bipartite graph definition you got, all the people got. Now let's see small changes. Listen, understand this. M here, N here. One more example, understand. M here, N here. So I'm writing directly bipartite graph, right? So previously what we are verifying, given graph is a bipartite graph or not. Previously I will give one graph, you have to verify bipartite or not. Now I am not doing that. I'm directly writing the bipartite graph because of you are comfortable. Is it bipartite or not? You are okay. So I'm writing directly. Now understand here. So suppose assume that it is 1 here, it is 2 here. So it is 3 here, it is 4 here, it is 5 here. Right? So 1, 2 in the M part, 3, 4, 5 in the N part. Remember, this is a bipartite graph. I'm not asking given graph convert or not. I'm asking whatever I written, is it a bipartite graph or not? Of course, it is a bipartite graph with vertex partition 2, 3. It is a bipartite graph. Bipartite graph with vertex partition 2, 3. So understand. One more bipartite. I'm not asking is it bipartite or not. I'm writing the bipartite graph directly. If you have any doubt, you can check. I am writing one more bipartite graph. Can you see here? I am writing one more bipartite graph. Can you see here? M here and N here. M here, N here. It is a 1, 2. It is 3, 4, 5. 1, 2, 3, 4, 5. So it is going to be, see this one. It is going to be, this is also bipartite. It is also, if you want, you can verify within the M, no edge. Within the N also no edge. Always edge from M to N. First one is a bipartite graph where M contain 2 vertices, N contain 3. No edge there, it's okay. If edge there, always M to N only. Second also bipartite graph, edge always from M to N. Right? Two examples I given. I'm not asking whether can you verify given one is a bipartite or not. So I written directly bipartite. Is it not satisfying any bipartite property? Check. M, right? M comma M union N. All vertices will come. Intersection, no vertex common. Edge is always from M to N. If no edge, no problem. If edge there, M to N only. Now let's take one more example. Can you see the one more example? Can you see the one more example? See this one? 1, 2, 3, 4, 5. See this. From this one, all people edge there. From these two, all people edge there. From these three, all people edge there. So this is also bipartite graph. Edge always from M to N. Within M, no edge. Within N, no edge. It is also bipartite graph. It is also bipartite graph. Next one. Right? Let me write one more. Let me write one more. 1, 2, 3, 4, 5, 6. Edge always from M to N. Let us assume. From 1 to everywhere I kept. From 2 to everywhere I kept. From 3 to everywhere I kept. Right? So this is also a bipartite graph. First one is a bipartite, second one also bipartite, third one also bipartite, fourth one also bipartite. Totally there are 4 graphs are there. All are bipartite. But observe clearly, in third one, it is the first diagram assume. Right? It is if you want, I will write the G1. It is the G2 assume. It is the G3 assume. It is the G4 assume. Totally there are 4 graphs. If you observe clearly, third one is a bipartite graph. Fourth one also bipartite. All are bipartite. But if you see the third one, right? I think right in the third one, 1 to everywhere edge there, 2 to everywhere edge there, 3 to everywhere edge there. Now see the answer. It is a complete bipartite graph where first part contain 3, second part contain 2. Why it is called complete bipartite? Why it is called complete bipartite? Right? In the M, right? In the M, if you take any person, that person is having edges with all the people of N. In the M, you take any person, that person having with all the people in the N. Second person you take with all the people in N. So that is the reason it is called complete. Complete bipartite graph with vertex partition 3, 2. If you see the fourth one also bipartite. Not only bipartite, is a complete bipartite 3, 3. Vertex partition 3, 3. So, but remember, so G1 is a bipartite graph. It is not a complete bipartite. I cannot write K2, 3. I cannot write here K 2, 3. I cannot write. It is not a complete bipartite. It is a bipartite graph. It is a bipartite graph, but not complete bipartite graph. Understand? Now understand. I am writing the one note. Note I am writing. Can you listen carefully? Can you listen carefully? In 5 vertex bipartite graph. In 5 vertex bipartite graph with vertex partition in 5 vertex bipartite graph with vertex partition 2, 2 and 3. 2 and 3. In 5 vertex bipartite graph with vertex partition 2 and 3. With vertex partition 2 and 3. Right? 1, right? I am writing one important thing. Please listen. 1. Minimum edges how many? Minimum edges how many? In 5 vertex bipartite graph, right? In 5 vertex bipartite graph with vertex partition 2 and 3, minimum edges how many? Minimum edges, I think M to N means this is M assume, this is N assume, right? So minimum edges are 0. It is a bipartite graph, not a complete bipartite graph. Second one, if you observe, maximum edges how many? Maximum edges how many? If you observe clearly, every vertex of M is associated with the every vertex of N, means first person having 3, second person having 3, like that 2 times. So 2 into 3, totally 6 edges. Right? I think you are okay. Now I am asking one small line. Now I am asking one small line. Understand this. Note. It's a very, very important one. Note. In n vertex, bipartite graph, in n vertex bipartite graph with vertex partition, with vertex partition, with vertex partition, understand here, n by 5 one side, comma, 4n by 5 another side. Suppose assume number of vertices are 100. 100 by 5 means 20 one side. 4n by 5 80 another side. In n vertex bipartite graph with vertex partition n by 5 and 4n by 5. N by 5 and 4n by 5. Right? Now my question is going to be 1. Minimum edges how many? Minimum edges how many? I think there may be no edge also. 0. 2. Maximum edges how many? Maximum edges how many? I think right, every vertex of n by 5 is associated to every vertex of 4n by 5. What is the answer? First time 4n by 5, second time 4n by 5, third time 4n by 5. Then what is the answer? N by 5 into 4n by 5, which will goes to, I think what is the answer? Upper if you see 4n square, below if you see 25. This answer. It's a very, very important one. It's a very, very useful also. Please careful. It's a very, very useful also. Please careful. So very, very less people can do it. In n vertex bipartite graph with the vertex partition n by 5 and 4n by 5, minimum edges are 0, maximum edges are n by 5 into 4n by 5, means 4n square by 25. 4n square by 25. I feel you are okay. I feel you are okay. Now if you okay, listen. Now if you okay, I am going to say one important one. Everyone listen. Remember, nowhere I used in these two notes, nowhere I used complete bipartite graph. I am talking about bipartite graph. Remember, when I say bipartite graph, then you will get the minimum edges, then you will get the maximum edges. If I say bipartite graph, then you will get the minimum edges, then you will get the maximum edges, minimum edges and maximum edges. Right? If I say bipartite, but if I say in some other way, right, there is no minimum, there is no maximum. If you want, you can check. See, this note is very important. This note is very important. See what I am doing. In, careful everyone, in k, careful, k means what? Complete. In k 3 comma 2, in k 3 comma 2, complete bipartite graph, complete bipartite graph. In k 3 comma 2, complete bipartite graph. See the answer. 1. Minimum edges how many? Minimum edges how many? 2. Maximum edges how many? Right? In k 3 comma 2, complete bipartite graph, minimum edges how many? Maximum edges how many? Minimum edges, if you see, listen, minimum edges if you see, are bhaiya, it is already complete. Yeah, it is already complete. What is minimum? What is the maximum? So minimum is going to be 3 into 2, maximum also 3 into, because it is already complete. Complete, we cannot do anything. Complete, we cannot do anything. Complete means complete. It's a very, very important one. Bipartite means minimum, maximum will come. Bipartite means minimum, maximum will come. But it's a complete bipartite, na? Complete means complete. Right? This is the very, very, people will confuse. Already mentioned complete. Complete means what? Every person should be mapped. Within M, no mapping. Within N, no mapping. If at all mapping there, it is not bipartite. First of all, it is a bipartite. Within M, no mapping. Within N also, no mapping. But mapping is always from M to N because of complete. Every mapping is allowed. Right? I think you are okay. Now I am saying one more note. Very, very important one. This is very less people can give it. Very less people. It is a very less people. So see that twist here. In careful. Observe, very, very interesting. Very, very interesting here. Very, very interesting. Observe here. In 10 vertex bipartite graph. In 10 vertex bipartite graph. Careful. In 10 vertex bipartite. But the question here is not divided, but he's saying it is a bipartite graph. In 10 vertex bipartite graph, 1 minimum edges how many? Remember he's saying bipartite, but he's not done the division, so you should be take care. 2 maximum edges how many? I'm expecting answer. Can you do this? He didn't mention the, and one more, remember it's a bipartite graph. It is not a complete bipartite graph. When you say bipartite, minimum edges possible, maximum edges possible. But the problem here is division is not done. Some people are asking, division is not done. So how should I do, sir? Do whatever way you like. Sir, division is not done. Nah? How can I do? Do whatever way you want, but I want minimum edges. Do whatever way you want. I want minimum edges. I want maximum edges. Right? So some people are asking, sir, how I will divide? Divide whatever way you like. Some people are asking, sir, can you divide? I'm trying. I think 10 vertices, na? So I'm trying. I'm giving roughly, can you see here? Roughly I'm doing. See this one. Remember, M cannot be empty, N cannot be empty. M here, N here. M here, N here. Can you see this? M here, N here. So 1 here, 9 here. 2 here, 8 here. 3 here, 3 here. I think 7 here. 4 here, 6 here. 5 here, 5 here. Now, if you observe clearly, next reverse, if you see 6, 4, I think above thing only will repeat. M becomes N, N becomes M. I think these are the possibilities. These are the possibilities. Now observe. These are the possibilities. If you divide like this, minimum 0, maximum is 9. If you divide like this, minimum 0, minimum okay. Because it is a bipartite graph, na? Don't keep any edge. Minimum 0, maximum 16. If you do like this one, a minimum 0, maximum 21. If you do like this, na, minimum 0, maximum 24. If you do like this, na, minimum 0, maximum 25. This is the answer. If you divide equally, na, if you divide equally, you will get the maximum edges. So minimum 0, maximum 25. You have to divide equally. So many answers possible, but he is asking maximum edges how many? How I will divide? Because he is not given division. How I will divide? If I divide what way, I will get maximum edges, find out. Minimum anyhow 0. So this is the answer. Because of he is not mentioned anything, simply bipartite. These all are correct, but I want maximum edges. If you divide like this, then you will get the maximum edges. It's a very, very important problem. This problem may come in the exam. This problem may come in the exam. Be careful. This may come in the exam. This may come in the exam. Be careful. I am keeping star operator also. 25 stars I kept. 5 5s 25. 25 stars I kept. 25 stars I kept. Please try to understand. It may come in the exam. It may come in the exam. Is it okay? It may come in the exam. Fine. And one more thing is, today is these all are our toppers. These all are our toppers. If anyone say YEPT, if anyone say YEPT, recorded is there, live is there. And daily quizzes also there. Doubt solving sessions also there. right? Doubt solving sense. And next one, 3000 pyqs with solution, 6000 practice questions, 3000 pyqs, 6000 verified questions, right? These all will be given to you. And one more thing, these all given. And one more thing is EPTA, as the name suggesting, exam prep tool, right? Goal is how to clear the exams. We don't teach unnecessary stuff. We don't teach less, we don't teach more. Whatever needed for exam, we will do it, right? Next one, right? Job notifications also we will provide. We will give the mentorship sessions also. Trial courses also available, please check. Trial courses also there, right? Right. Next, subject matter experts will solve your doubts. And AIR1 notes also you can get it, AIR1 notes, right? Quality study material also provided, everything whatever is needed for example, we will provide everything. So right, we'll provide everything. And one more thing is there is a test series, right? 2026 purpose, those people who are doing 2026 purpose, test series is there, RIC course there, you can utilize. So those people, for 27 people go for regular, 28 people go for foundation, 26 people can go to the crash course, rank improvement course, test series. 26 people can go to all these things, right? Right. And one more thing is, as I mentioned to you, 80% discount going on. Today is the last date. 80% discount going on. Today is the last date. Please utilize. 80% discount going on. Right? 26 people can go for RIC course and test series. 27 people can go for, right, regular course. 28 people can go for foundation course. Placement people can go for a DSA and placement course. DSA and placement course you can go. Small doubt also there, you can WhatsApp us. It's a WhatsApp number. You can clarify your doubt. It's a WhatsApp number. You can clarify 888208990. It's a WhatsApp number, right? You can clarify your doubts and you can continue the preparation. Right, perfect. Thank you. See you in the next class. See you in the next class. Right, fine. Tomorrow onwards, classes will be there in the EPT platform. Tomorrow onwards, classes will be there in the EPT platform. Thank you. Thank you, everyone.